So, hi everybody. My name is Giulia Renda, and the talk that I'm gonna do examines how narrative visualization bridges data and meaning in digital humanities, with the focus on semantic web learning. The presentation reflects on visualization as an epistemic tool to foster critical thinking, highlight data quality issues, and support data literacy more in general. I want to start with a sort of provocation, saying that in the semantic web, everything has structure, yet nothing has meaning until we do something with it. Okay? That's true to a certain extent, of course, because as we all know very well, semantic web data is structured, is formal, and machine readable, all aspects that makes it really powerful. Okay. However, it does not inherently carry meaning for human users. Cultural heritage professionals and digital humanists encounter this gap all the time. Even when they successfully extract link and open data through a SPARQL query, if they manage, they still need to interpret what the results mean. And this gap is not just technical in this sense, it's cognitive. And this is especially relevant in the humanities and in cultural heritage, where data needs to be contextualized and interpreted, not just accessed in order to create new knowledge. In my research, I explore this challenge from two main angles. The first one is designing tools that make interpretation and querying inseparable, like the software called Melody that we are going to see, which connects SPARQL query execution with visualization and narrative construction. The second angle, instead, is observing how visualization actively shapes understanding, especially in educational settings where users are learning semantic web technologies from scratch. So they are really beginners. In this perspective, the question is, what happens when visualization is not just a way of showing data as a final output, but a way of thinking with it? So, yeah, visualization, I work with visualization not as a final output. It doesn't mean that we cannot. This is another perspective on it. It's a working surface for interpretation where users explore patterns, confront problems, and make sense of uncertainty, for example, as Tommaso teached us earlier. Okay. In this frame, the narrative component works alongside visualization. It guides interpretation, frames the visual part, and explains what the data means or what it hides, for example. So in my research, visualization is more than an output and becomes an epistemic practice, a space where knowledge is built, questioned, and made visible. This aspect that I just mentioned, so iteration, for example, pattern finding, in interpreting, can be formally framed as exploratory data analysis and knowledge discovery that together play in this meaning-making process. In this view, visualization and narrative storytelling form the link, in my opinion, between the formal logic of semantic web and the interpretative logic of the humanities. I mentioned very briefly Melody, that is the place where hopefully this process can take place. Melody is a web-based editor that lets users combine in one place SPARQL queries, interactive charts, other type of components, and most importantly, explanatory text blocks in a single linear data story. Now, I'm gonna be brave and try to show you this very brief video really quickly. This is what a user sees as when it starts to create a data story. So you see my first data story as a title. There are some components here at the bottom, text, some components, charts, tables, and so on. Whoops, spoiler. The user simply needs some working Sparkle query. In this case, we are selecting a bar chart and inputting a working Sparkle query, and this the chart is immediately visualized. Okay, yes, okay, like this. Immediate feedback. The final output, imagine adding text before or after this chart, a second, a third chart, a count element, and so on, becomes the final output of an HTML document that is a data story that alternates text and charts to convey a message, to create knowledge, to explore a dataset, for example. But what makes this interesting is not the output per se, but the fact that querying and interpreting happens in the same space, something that in my research I didn't encounter, for sure, in open source softwares. So the user has an immediate feedback on their query and can respond, refine, and question. Okay. This began as a storytelling tool mainly targeted to researcher, but became a research environment in itself because it gave us the possibility to observe how people construct meaning from structured data. That is how we arrived to a dataset of 51 data stories, because during a master course here in Bologna, students used Melody to create a data story in the learning process of learning semantic web technologies for the first time. So we have stories and all their components, meaning that we collected all the Sparkle queries, the visualization type, number, positioning, text, if the project was a collaborative one or not, and finally written student feedback on the challenges that they encountered during the creation of these data stories. We analyze this data set with a mixed method approach. First of all, we generally explore the data set, checking components, their usage, their ordering, the text, even the Sparkle queries in itself. For example, how many triples compose these queries. We defined some metrics, one to measure Sparkle proficiency, another one for the storytelling quality, and a third one for the good alternation of storytelling. We use this metric to plot correlation and clustering because we were very interested in understanding if these three main skills, so SparkQL, data visualization, and storytelling, co-evolve together in some sense. And then finally, we qualitatively analyze students' feedback. I'm gonna focus on these two last aspects, so co-evolution of skills and students' feedback mainly. Before going into detail in the findings, I would like to tell you what we expected at the very beginning. First of all, we expected to find some interconnection in the development of these three skills. We expected to find visualization used as a bridge to support, for example, debugging in the query building. And finally, in our opinion, collaboration was a plus, meaning that a group of people would have achieved a data story of higher quality. What we did find instead? First of all, it was very clear that mostly technical skills and narrative quality do not go hand in hand. We did find some correlation, some significant correlation between Sparkle proficiency and coherence, meaning that narratives were semantically well structured, where queries were also good. But on the other hand, we understood that students who wrote correct queries often produced texts that were harder to understand from a readability point of view. And this highlights a sort of trade-off. Cognitive effort goes either into writing the Sparkle queries or into communicating. The second finding was that data stories that had a good level of Sparkle proficiency tended to use fewer visualization in a more strategic way, while instead a lower quality in SparkQL led to have data stories full of data visualization in a sort of way of demonstrating that they were learning data visualization. We need to say, though, that on average, all users preferred well understood formats of data visualization, such as the table. As you can see, it's the most used type of visualization. What we can say instead about the structure of the data story, meaning a good alternation of text and data visualization, is that it did not correlate with Sparkle proficiency. Several stories, we can say, though, that the denser the story in terms of component, the less amount of alternation they displayed. In general, we can, there is not much correlation, but we can highlight some patterns. Generally, several stories tended to use text at the beginning to frame the data visualization and not alternate much later on. What about correlation? Collaboration does not guarantee integration of skills. Even though we need to say that generally teams were very small, so we can say that the division of the clear-cut division of task was almost mandatory to finish the project, though the expectation that we had did not have not been matched. Even though findings were not good, but surprising in a sense, we can still say that visualization was repeatedly named in feedback as the moment when things started to make sense. That's something that was very important for us because written feedback from students said that in the moment that they visualized the query that they produced, they could see, for example, where the query were incomplete or where data was inconsistent. In this sense, visualization sparked an iterative process that drove revision, learning, and discovery more than any other component and aspect of this experience. So, based on these okay, last slide, I'm at the end. Based on these findings, we can draw some implications for DH teaching and tool design in general. Again, the goal is to see visualization as a method in the learning process. So the idea is to teach visualization early, not as a post-processing step later on. Query, Sparkle proficiency and narrative quality don't always grow together, but the idea is to teach them in parallel, okay, in order to have data extraction and interpretation happening at the same time and feeding themselves. So it would be advisable to have tools that support this parallel learning. We should train more students to define what a visual is doing in the story and not just using them as much as possible. Any chart doesn't mean good story. Since visual loops is so good in supporting critical thinking, tools should allow for this iteration of query, visualization, and refinement. And finally, something that I'm really passionate about is the fact that frustration is part of learning. So we should not try to make their life too simple in this sense, because we should harness, okay, this frustration because it's part of mean making. Finally, the last sentence that I want to leave you with is that narrative visualization is not a wrapper for data. It is a means of interpretation and method for making meaning from structure. Thank you very much.
Thank you very much. Very good list of implications. Any questions? So one thing that struck me is that I'm not sure if this is sort of a confounding factor, but what I've noticed often in talking with scholars thinking about using visualizations is the clarity of their own question or story that they're trying to tell. So some people have just very vague notion and then play around and then never really get to it. And so the entire process is frustrated by not really knowing what they want. Whereas others with very concrete and very clear thing, and then it's just 5 steps and they're done. So is this something that you think is an important factor in there? Is it something you encountered or considered?
Okay. I think that it's quite normal to find frustration in the creation of a data visualization, especially if you don't have a background on it. I would start a step even before that, that as digital humanists, we should be literate, at least a good amount on data literacy in general, because in the world we live today, this world of data, it is everywhere. You need to at least to try and understand the basic. That means how you can construct, for example, a bar chart. That is a very simple one. It's not even a mean of what tool to use, because nowadays there are very easy ones. So I would start even before. So when we teach to students, for example, including data visualizations in contexts more technical, such as learning semantic web technologies, should be used as part of the learning process, so that you become a researcher that can easily use data visualization in the communication of your research. I don't know if that answered the question to some extent.
Well, so I'm thinking of even a step before that. Okay. People have an idea of what story they want to tell, or what thing they want to explore. So before they even get to the data and thinking about visualizations, is just how clear is the thing that they have in their head of, this is the thing I want to tell. Okay.
That is then I think a matter of communication strategies. For example, I didn't include that a chart about feedbacks. The students were from communication and languages. So for them, the storytelling part was the easiest one, and the one that made them more comfortable in what they were doing, because they were learning data storytelling, the data visualization and SparkQL from scratch completely. And that helped them in the learning process, being confident at least in one of the 3 aspects. So I would say that, it's something that you can learn how to communicate and how to give form and shape to what is the idea that you want to communicate. So that is more on the communication strategy part than on the visualization. Of course, in order to create a good data visualization, you need to have clear in mind what you want to communicate. So yeah, that's, I think, many steps before the data visualization.
Yeah. Okay, any other questions? Oh.
I think now you mentioned working with students from communication, right? I wanted to ask how difficult or how much an obstacle was the SparkQL part, and if this kind of process is always meant to be managed in a sort of multidisciplinary way, or if somehow the the aspect of communicating the intricacies of using Sparkler is is somehow mitigated in the process, and yes, that's it. I just wanted to know how difficult it was to integrate this part to people that are not acquainted with that. Thank you.
Just me. Okay.
Without breaking anything.
Thank you. There are several aspects to this question. The first one is that I was not the one teaching them Semantic Web. What I can say from my perspective is that I teach sometimes to students from the master degree of the HPK, and it's difficult with them that has already did an exam on SparkQL. So it was for sure very difficult for students coming from a language and communication background. As you can see here, hopefully, I designed a metric to measure SparkQL proficiency because there isn't any. I don't know how much it is reproducible because I kept in mind the context in which I was analyzing SparkQL proficiency. But apart from that, you can see that values ranges from 0.1 to 0.6. Okay, so you understand that it is low. Okay, we have no stories that go to 0.8 or 0.9, for example, of SparkQL proficiency. So in general, it was very low. And what they told us in the feedback is that they found it very challenging, very, very challenging. But for sure, visualizing immediately the data allowed them to understand, first of all, that the query was not working, okay? But also to add complexity to the query. I don't have the logs, unfortunately. It would be very interesting to see the evolution of the queries. But what you can see is that they started to add them, and they mentioned that, for example, the optional construct, okay, or the distinct or the filter and so on. So, or even federation, when they understood that they needed data from somewhere else, they integrated with the federation. So visualizing helped them in the learning process of SparkQL. That's
because the efficiency assessment, it's a self-test?
No, I do, based on I don't check the number of triples, for example. I check the usage of constructs and the usage of federation, if the query is working correctly and so on. There are several aspects mixed that created this metric. I don't know if there is already something published on them. There is one paper under review, but I can share it in any case.
Okay, that's all we have time for, so let's thank our speaker again. And we have the last presentation by Lucia Giulia, representing Born Digital Archives. Thank you.